Welcome to our Chapter 3 video on descriptive statistics, and in particular on the population data as opposed to sample. We're going to be looking at an example problem that's found in your folder there from Blackboard. Print that out if you haven't done so, please. So pause the video if you need to at this point in time. Now continuing. We're looking at this example where we're dealing with a chess tournament, and it mentions all 10 of the participants. All 10 indicates population. That's the part that tells us we are dealing with population data as opposed to sample. And it's given us a list of 10 data values, the ages of those particular participants. I've entered that data into my 83 calculator. The previous video showed us how to do that. We would go to Stat, Edit, and I've already got that list in there. Enter that if you haven't done so. After entering the data, remember you hit Stat, Calculate. Flashing for which one? Default being List 1. And it gives us these different values. The ones that we're going to need, the sum of the x values, and the sum of the x squared values. So those are just the couple values that are going to be used in the formulas. We'll pull up the calculator in a little bit as we deal with other parts of the problem. So, first of all, with the mean. Notation is mu. Formula for the arithmetic mean is the sum of the x's over n, where n is the number of data points. So from our calculator, we found the 638 as the sum. 10 was our value of n. From the calculator, we can pull off the average 63.8. Even though it says x bar, the calculated value for the population mean and the sample mean are the same. For the standard deviation, notation for that, for the population, is sigma. Looks like a circle with a little tail. Its formula, this you should have used given in that getting started assignment. N times the sum of the x's squared minus the sum of the x values squared over n squared. Substituting this into our formula, we have every one of those values. N is 10. We have the sum of the x squares, which is 43,086, minus our 638 squared. And the sum of the x's squared is not the same as the sum of the x squares. Those are two different items. Over 10 squared equals. And again, you can pull that directly off the calculator with our sigma x. 15.43. For the mean, that's one place value beyond the data. For the standard deviation, that's 2 place points, 2 place values beyond the data. For the coefficient of variation, the notation here is CVAR. Its formula for population, sigma over mu times 100%, because it is a percentage of variation and allows you to compare different data sets. For our particular example, standard deviation is 15.43. Our mean was 63.8. Times that 100%, because it is a percentage, equals. And this one you can't pull off the calculator. If you look at that screen, notice that there is no value for CVAR. There's a lot of different things down there, but not CVAR. So you actually have to enter that into the calculator, and that is a 24.2%. So those would be the different calculated values for this particular problem. As I'm grading this problem, I would be making 4 check marks for the mean, 4 for the standard deviation, and 4 for the coefficient of variation. So 12 particular check marks that I would need to make for this problem. Any one of them missing are points off. You need that at least. You don't have to input the part that's in blue, but it doesn't hurt. That would be this example on calculating population statistics.